Beneath the frozen surface of Jupiter's moon, Europa lies an ocean deeper than all of Earth's oceans combined. And something in that ocean might be alive. We're about to find out if we're alone in the universe, and the answer could be waiting just 390 million miles away. Forget searching distant galaxies for alien life. Forget looking for radio signals from civilizations light years away. The most likely place we'll discover extraterrestrial life is right here in our solar system. Under miles of ice, in complete darkness, in an ocean that's existed for billions of years, conditions might be perfect for life to emerge and thrive. This is Huddle Videos, and today we're diving into Europa, Jupiter's mysterious moon that could rewrite everything we know about life in the universe. In 1979, Voyager 1 swept past Jupiter and sent back humanity's first close-up images of Europa. Scientists expected to see a heavily cratered moon, scarred by billions of years of asteroid impacts like our own moon or Mercury. Instead, they saw something that made no sense. Europa's surface was almost completely smooth, barely any craters. Instead, the moon was covered in strange cracks, ridges, and chaotic terrain that looked like broken ice on a frozen lake. One scientist looked at those images and said words that would change planetary science forever. "This moon has an ocean underneath." The implications were staggering. If Europa had liquid water and lots of it, it could potentially harbor life. As more data came in from subsequent missions, the evidence mounted. Europa's surface is water ice, but it's young. Geologically speaking, only about 40 to 90 million years old. Wait, how do we know the ice is young? Craters, or rather the lack of them. Space is filled with debris constantly bombarding planetary bodies. The moon's surface is ancient, so it's saturated with impact craters. Europa should be too, given its position in the solar system where it's exposed to the same cosmic shooting gallery. But Europa's surface has very few craters. The only explanation? The surface is constantly being renewed, resurfaced from below. Something is erasing the old ice and replacing it with fresh material. That something is an ocean. Imagine standing on Europa's surface, looking at massive ice ridges towering hundreds of feet high, crisscrossing in chaotic patterns. Beneath your feet, hidden under miles of ice, is more liquid water than exists on all of Earth. A global ocean, wrapped around an entire moon, sealed beneath ice for billions of years. It's one of the most profound discoveries in the history of space exploration. So how big is this ocean? The numbers are mind-blowing. Europa is slightly smaller than Earth's moon, with a diameter of about 1,940 miles. The ice shell is estimated to be 10 to 15 miles thick. That's the frozen ceiling of the largest ocean humanity has ever encountered. Beneath that ice, the ocean extends down 40 to 100 miles deep. To put that in perspective, Earth's deepest ocean point is the Mariana Trench at about 7 miles deep. Europa's ocean could be more than 10 times deeper. The total volume of water in Europa's ocean is estimated at 2 to 3 times the volume of all Earth's oceans combined. We're talking about an unimaginable amount of liquid water, more than exists anywhere else in the solar system besides Earth, and it's been there for billions of years. But here's the question that haunted scientists: how is this water still liquid? Europa is 484 million miles from the Sun on average, more than 5 times farther than Earth. At that distance, solar heating is negligible. The surface temperature is around minus 260 degrees Fahrenheit, minus 160 degrees Celsius. Water should be frozen solid. The answer is tidal heating, and it's absolutely fascinating. Europa orbits Jupiter in a slightly elliptical path. As it gets closer to Jupiter, the massive planet's gravity pulls on Europa, squeezing and stretching it. As Europa moves farther away, the gravitational pull weakens. This constant squeezing and stretching generates friction inside the moon, and friction generates heat. Enough heat to keep an entire ocean liquid for billions of years. Think about that. Jupiter's gravity is essentially kneading Europa like dough, and that mechanical energy keeps the ocean from freezing. It's a heat source that doesn't depend on the sun, doesn't depend on volcanic activity, just pure gravitational physics. But tidal heating does more than just melt ice. It likely creates hydrothermal vents on Europa's ocean floor. On Earth, hydrothermal vents are underwater volcanoes where superheated, mineral-rich water spews from cracks in the ocean floor. These vents support entire ecosystems in complete darkness, miles below the surface where sunlight never penetrates. Tube worms, shrimp, crabs, bacteria, all thriving in conditions that would seem impossible. They don't need sunlight. They use chemosynthesis, deriving energy from chemicals in the vent water. Scientists believe Europa's ocean floor likely has similar vents. Tidal heating would crack the rocky mantle, allowing water to seep down, get superheated, and shoot back up, carrying dissolved minerals and chemical energy. Which means Europa might have all the ingredients for life: liquid water, chemical energy, and billions of years for evolution to work. The parallel to Earth is impossible to ignore. Life might have originated around hydrothermal vents on Earth. The same process could be happening right now on Europa. In 2012, the Hubble Space Telescope detected something extraordinary: giant plumes of water vapor erupting from Europa's surface, shooting up to 125 miles into space. This was a game changer. These plumes mean the ocean is actively venting into space. Cracks in the ice open up, pressure forces ocean water up through the cracks, and it sprays into the vacuum like a geyser. And here's why this matters. If there's life in Europa's ocean, fragments of that life, organic molecules, microbes, chemical signatures, could be carried up in those plumes. We might be able to detect alien life without even landing on Europa. We could fly a spacecraft through the plume, collect samples, and analyze them. Imagine that. Discovering extraterrestrial life by flying through a geyser on an alien moon. Spectroscopic analysis of Europa's surface has revealed something intriguing. Salts, specifically magnesium sulfate and sodium chloride, table salt. These salts didn't come from the ice shell, they came from below. They're oceanic minerals that got carried to the surface and deposited when the water froze. This tells us the ocean is salty, similar to Earth's oceans. And it's chemically interacting with the rocky seafloor, which means chemical cycling, mineral exchange, energy gradients, all the things that support life on Earth. Scientists have also detected oxygen on Europa's surface, created when radiation from Jupiter breaks apart water molecules. Some of that oxygen might work its way down into the ocean through cracks and mixing processes. Oxygen, salts, chemical energy, liquid water. The recipe for life keeps getting more complete. There's one more tantalizing possibility. Europa might be geologically active right now. Galileo spacecraft data from the 1990s suggested Europa has a weak magnetic field that varies over time. The best explanation? A salty, electrically conductive ocean moving beneath the ice, generating currents that create magnetic fluctuations. That means the ocean isn't static. It's churning, moving, circulating. And if it's circulating, it's mixing nutrients, distributing heat, creating the dynamic conditions that life needs. Think about what might exist down there. In the absolute darkness, in the icy cold pressure, perhaps near a hydrothermal vent glowing faintly in the black water. Could something be alive? Could there be microbial communities coating the rocks? Could there be something swimming in the currents? Could billions of years of evolution have produced something we'd recognize as life? We don't know. Not yet. But we're about to find out. In 2024, NASA launched the Europa Clipper mission, the most ambitious exploration of an ocean world ever attempted. This spacecraft, the size of a basketball court with its solar panels deployed, is currently on its way to Jupiter. It will arrive in 2030 and begin a series of close flybys of Europa. Clipper won't land on Europa, not yet, but it will fly through those water plumes, analyzing their composition. It will use ice-penetrating radar to map the ocean beneath. It will photograph the surface in unprecedented detail, identifying the best landing sites for future missions. Most importantly, it will search for biosignatures, chemical markers that could indicate life. The instruments on Clipper can detect organic molecules, analyze salts and minerals, measure the ocean's depth and salinity, and determine if the conditions are truly habitable. Within this decade, we might receive data that tells us whether Europa's ocean contains life. That's not science fiction or distant future speculation. That's happening in our lifetime. But the ultimate goal is more ambitious. landing on Europa and drilling through the ice. Future missions are being designed to do exactly that. A lander equipped with a cryobot, a heated probe that can melt through ice, could tunnel down through the miles-thick ice shell. Picture it, a probe descending through the ice, deeper and deeper, transmitting data back to the lander on the surface. Temperature readings, pressure measurements, chemical analysis of the ice layers. Then, after days or weeks of melting downward, the probe breaks through the bottom of the ice shell and enters the ocean. Its lights flick on, illuminating an alien sea that has been hidden in darkness for 4 billion years. What would those cameras see? Would the water be clear or murky? Would there be particles drifting in the current? Would something move in the light? That moment, if it happens, will be one of the most significant in human history. The first time we've ever explored an alien ocean. The first time we've looked for life beyond Earth in its own environment. Europa Clipper arrives at Jupiter in 2030. Its primary mission will last about 4 years, conducting multiple flybys and gathering comprehensive data. A lander mission could follow in the late 2030s or 2040s, depending on funding and technological development. That means people watching this video right now could be alive when we discover life on Europa. Students in school today could be the scientists analyzing the data. Children being born now could grow up in a world where we know we're not alone. The search for life isn't some distant dream. It's happening now, and Europa is our best shot. If we find life on Europa, even just microbes, it would be the most important discovery in the history of science. Here's why. If life emerged independently on 2 different worlds in the same solar system, it means life is probably common in the universe. Think about it. Earth and Europa are both in our solar system, but they're wildly different environments. Earth is warm, bathed in sunlight, with a thin atmosphere and shallow oceans. Europa is frozen, dark, with miles of ice separating its ocean from space. If life emerged in both places, it suggests that life arises wherever conditions permit, and there are billions of potentially habitable worlds in our galaxy alone. We wouldn't be rare, we wouldn't be special. We'd be part of a living universe. Europa isn't alone. Saturn's moon Enceladus also has a subsurface ocean and active plumes. Saturn's moon Titan has liquid methane lakes on its surface and possibly a water ocean below. Jupiter's moon Ganymede likely has an ocean too. Our solar system might be teeming with oceans, and if there are oceans, there could be life. The paradigm has shifted. We used to think planets in the habitable zone, the narrow band around a star where temperatures allow liquid water, were the only places life could exist. Now we know better. Moons orbiting giant planets can have oceans heated by tidal forces, regardless of how far they are from the sun. That massively expands the number of potentially habitable worlds in the universe. Europa taught us that life doesn't need sunlight. It doesn't need a warm planet. It just needs liquid water, chemical energy, and time. And the universe has plenty of all 3. The hidden ocean of Europa has been waiting for billions of years. Sealed beneath miles of ice, protected from the harsh radiation of Jupiter, its dark waters might harbor the first alien life humanity ever discovers. We're closer than ever to answering the oldest question: are we alone? Within your lifetime, we might receive a transmission from Europa Clipper showing chemical signatures of life in those plumes. We might see images from a lander on Europa's surface, preparing to drill through the ice. We might watch as a submersible explores an alien ocean, searching for organisms that evolved completely independently from anything on Earth. That's not fantasy, that's the trajectory we're on. Europa represents hope, hope that life is resilient, creative, and abundant. Hope that the universe is not a barren wasteland, but a garden of possibilities. The ocean is there. The mission is launching. The answer is waiting. And when we finally peer into Europa's depths, when we finally discover what swims in those ancient waters, everything changes. If this video ignited your sense of wonder about Europa, we are tracking the Europa Clipper mission closely. If you want to see the first images of that alien ocean the moment they arrive, make sure you're subscribed. You won't want to miss what comes next. Comment below. If you could send one instrument to Europa's ocean, what would it be? And remember, some of the most profound discoveries aren't light years away. They're right here in our cosmic neighborhood, hiding beneath the ice. Until next time, keep looking up and down and everywhere the universe hides its secrets.